Okay, let's go.
Good evening, good morning,
Hello.
good afternoon. Hey everyone, and welcome to the first, or actually second, live stream of this hackathon. My name is Senda. I'm a product marketing manager here at Speckle, and with me is
Mirna, and I'm full sentence content and social media manager here at Speckle, and this is my first Speckle stream. I'm very new to the team, so it's very exciting.
It is exciting indeed because we are here to introduce one of the four categories of this hackathon today, and it is the Project Pulse category. As hopefully all of you know, the AC industry is struggling with collaboration, and Speckle is here to bridge the collaboration gap in AC. This category was designed with that in heart, and we are introducing the judge of this category, which I will let Mirna tell you more about.
Yes, the judge of this category that I hope that you've read about before, because it was a very interesting article and interview as well, is Marta Tsigkari from Foster+Partners. She is not only an associate professor at UCL, the senior partner of Foster+Partners, but she is also the head of applied research and development group there that does a lot of very magical and cool and strange things with AI and machine learning. She is very future focused, and that's why we think that she's the perfect Project Pulse judge, because your projects probably need some boosting of the pulse. And if you have that itch that needs to be scratched and really want to contribute to that part of the AEC, we suggest that you watch what Marta has installed for us. She unfortunately can't be with us here live because she is probably very busy or taking a break from her full day because it's pretty late. But let's see what she prepared.
Yeah, we're happy to have a golden recording, and we're about to share it with you all, so be prepared and tune in. Let's go.
And thank you, first of all, for inviting us to speak today. We love talking about the future, and we love speaking also with people we know very well, like nature. So thank you for the invitation. A little bit about me. I have joined Foster+Partners 18 years ago. I'm very happy and privileged to be in a company that explores the potential of technology every single day and gives us the opportunity to use it in many interesting projects. I myself am the head of Applied R&D, which is a close-knit group at Foster+Partners dedicated to cutting-edge research. And our background spans from arts and architecture to engineering, software development, data science. But our common denominator is that we're all programmers. And we have a wide breadth and depth of expertise, ranging from complex geometries and performance in design to operational digital things, optimization, and AI. And we keep asking technology questions to ourselves, like what technologies exist out there that can help us reshape and optimize our industry today, not in 5, 10 years. And it's very industry because technology effectively allows us to make dreams into possibilities in a way. And these possibilities can transform not just the way we work, but also what we're able to do. And so technology provides us with the tools that make something like what could have been the design for Mexico City Airport possible. And I always like saying that most of these technologies that are transforming our industry really come directly from within the AAC. They're usually developed for the games, fields, and computer science industries before we realize the potential they can hold for our industry and revolutionize it by using it. So I'll give you a few examples on that. We'll start with GPU computing now, with NVIDIA being such a big player for some time on that. It's a technology used predominantly to accelerate computer graphics and to initially allow real-time interaction in games, and a lot of cards and a lot of different offerings exist out there. But GPU computing has also the potential to turn performance-driven design in our industry from an affair of hours and days to a real-time experience. And for us, real-time feedback is essential in the design loop. We have different performance KPIs that are key, but their analysis requires computationally expensive and time-consuming tasks to take place. And I'll give you an example of Cyclops, which was and is our in-house environmental and use analysis ray tracing tool that we started working on in 2007. And back at the time, we were doing it in order to analyze views on Stadia, and we could run 24 views per minute. But today, with the help of GPU computing, we can trace over 600,000 views per minute by simply taking advantage of the compute power available to us. This means that we can now run ray tracing analysis on a city scale in real time, therefore allowing our designers to check how well their design options perform as they create them. This is a tool that has now been deployed to the entire office and not only allows for real-time analysis, but also can provide real-time reports with a click of a button. So real-time technology developed for gaming has been upgrading not only our simulation, but also our design experiences. So using game engine software, we have developed tools like Thalia that you see on the screen and a tool before that called Sandbox, which were interactive applications powered by Cyclops that work a little bit like Minecraft in steroids, where the user can create and analyze various solutions in an array of different interfaces. And platforms like Thalia can empower designers to calculate and compare key metrics for their options in real time, allowing intuitive yet informed decision making early on in the design process on things that involve not just daylight areas, but also up to well-being indexes or embodied carbon calculations. Another capability that first thrived in the visualization and film industry before being introduced to the AC is distributed computing. And by moving distributed computing from faster image rendering to model creation and analysis, it has become the type of technology that help us turbocharge our optimization capabilities. And again, back in the day, we would use genetic algorithms to optimize just buildings, as you see here on the screen, where you counteract different objectives that may competing with each other, like in this case, structural viability and use to get a result out of the computer. But today we want to do these things on city scales. And I'll give you an example with our winning competition for the government hub in China, where we were interested in developing an urban layout that maximized particularly KPIs like connectivity between the different neighborhoods, use towards the central field, daylight, and a total floor area. So in the same way, we could spend months creating and analyzing thousands of options manually to find the best performing ones. But instead, what we did was fitting our requirements and design rules to the computer and allowed it to do the heavy lifting for us. So the genetic algorithm in and of itself generates and evaluates thousands of options and evolves the better performing solutions for us to start working from. And while this process would otherwise take around 3 months to calculate it, when it's done manually, we have developed an in-house bespoke application called Hydra, which is a distributed computing system that manages to run this optimization with these tens of thousands of options in a matter of a night. And we have also developed a web interface for this application that takes the pseudo optimal solution space at the end, allows us to visualize it against the different characteristics, and also prepare reports again in real time. With a click of the button again, we do like our reports. Technology not only helps us design better, but also better connect with each other, whether in terms of software or in terms of experiences. And for the software, for interoperability within software, it's key. And we are at the Spectral conference, so you all are very much familiar with that concept. I would like to say that many years ago at ARD, we have developed a tool, even before Spectral was out, and Matteo was part of the development as well, called Hermes, that allows for changes in the design process that are happening by different people that work in different software to be reflected in real time to all the users. And as you all know, as Spectral users, this not only better connects design intent amongst all stakeholders, but also permits substantial design changes to happen late in the process. And this is exactly what happened with our Lusal towers, where we had to effectively drop the tower by 10 floors. And this required reconstruction of the entire geometry that was made possible within a tight time frame before we had to deliver it within a week, just because we had Hermes for us to work. And in this case, we had Spectral. But as I mentioned before, collaboration is not only about software and spaces, but also experiences. Because as designers, we are in the business of creating experiences. And extended reality is yet another technology that came to revolutionize the way we work. And again, it did not come from within our industry. Augmented and virtual reality have the potential to transform the way we experience the environment around us and have our special experiences customized in real time. As you see here, my colleague said how with his Vision Pro trying to interrogate Swiss Re just outside our offices. For 15 years, for 15 years, we have been investigating the potential of virtual and collaborative spaces. And this has led to the development of Cloud, which is our bespoke XR platform, which we have used for on-site review processes like planning applications, immersive experiences, and digital mockups. And not only that, but as with all applications, we're trying to get cloud on the hands of our designers, which means that we now also have authoring tools and viewer tools directly integrated with our modeling software that allow our designers to configure their own experiences directly from Rhino and be able to do things like digital mockups, more or less, I don't want to say in real time, but very, very fast. And this ability to completely augment and extend our reality has not been more to any time else now with the metaverse, like the idea of creating these multiple virtual spaces. And we have created our own metaverse, which is effectively our office, our digital office as a sandbox, where we can have different experiences, going into meetings, allowing us to see how the digital team of the office works, being able to delve into presentations, etc. So there are a lot of different possibilities that extended reality can offer to optimize the way we design and how we collaborate. So moving from headsets to planes, it was the aviation industry that introduced many decades ago the implementation of digital twins in their design process. And as you heard, we already have a digital twin in our office. RVAC has been fully adopting this notion in order to optimize a business experience for its occupants long after its delivery. And fitting back in the design process. So it's not just a digital twin as an extension of the building management system for MVP, but it's also much more around how we as occupants experience spaces and are able to optimize them based on the feedback we get from the systems. At Applied R&D, we have developed a digital twin for the office. We developed our own IoT toolkit and a smart space application that is deployed office-wide. And that's all in the spirit of eating our own dog food and trying to understand how a digital twin would work, what are the different inputs that we need to put, what are the outputs, what are the data that we're getting, and how this can help us optimize how we occupy the space or things that we can do to make things better for people working here. And it's very interesting because digital twins can be very helpful, not just during operation, but also particularly during construction. And as early adopters of Boston Dynamics Spot, we tried to test this notion while simultaneously closing the loop between digital and physical state of the building. So we used our Zero Gardens residential development as the test bed during COVID, with Spot taking multiple scans on a weekly basis, comparing as design models against as-built reality. But when talking about technologies that came outside VAC but will have a profound effect in our industry, we can't but talk about machine learning and AI, which have the potential of bringing an unprecedented change in our profession. And I know that most of the time when we talk about AI in our industry, most people think things like ChatGPT or Bing Chat or Claude when it comes to LLMs, or when it comes to diffusion models with Journey and DALL-E and Firefly. But the reality is that with the development of new multi-model, zero-shot models, and with this API-first approach that every system has, we are seeing the creation of completely different content, like movies and 3D models, simply by using few images or descriptions. And more importantly, we're seeing the connection of all these different software together automatically through workflows. And we know now that our data can power a multitude of machine learning-driven applications, from design to construction and even down to operation. But to harness AI's power, we first need to be able to control that process, and that's data. And this is something that I don't feel many people really understand, how important it is to harness the data that we have organized in a way that we can further use it. And I don't think people really understand the huge amount of data that is produced, not just during design, but also construction operation of the built environment. And if we start with design, I will give you an example. We talked about Hydra and how it's capable of creating hundreds of thousands of options and analyzing them in a matter not of days or weeks, but hours. So just imagine, in a matter of hours, we produce thousands of solutions on a city scale, but also tens of thousands of analytical results that tell us how well the solutions perform. So could we use these rich data sets to train the computer to predict optimal space configuration? We can take these optimal data sets and start building applications that allow us to create predictions of different model configurations that we can then again use as a starting point to further expand our design. But there are many key areas where AI is expected to impact the field of architecture that is beyond generative AI. And so I will show you a few things that we start developing here at Applied R&D since 2017, actually. I will start with surrogate models. Surrogate models are machine learning models trained on huge data sets to replace slow analytical processes. And we have been developing such models for analysis, like visual and spatial connectivity, since the early 2020s. Let's escape and restart this. It's interesting every time we talk about technology fails us, and that should tell us something. So with the circuit models, we're having orders of magnitude faster predictions of what the analysis could be. And to make them accessible office-wide, what we've done, we have developed a Rhino ML plugin that could be used directly by any architect in the office, taking advantage of an ML inference API that we have developed. So here you see somebody in Rhino directly predicting special visual connectivity of this flow plate. Knowledge dissemination is another huge aspect of AI. And to that end, we have been working on an AI-powered search tool for the office called Foster+Partners. This has been deployed office-wide, and what it does a semantic search in our very valuable design guidelines, and allows people in the office to search the guides using simple queries and getting back instant answers. And we're also extending the systems to different data sets, including our materials research center, as well as to the drawings, detailed drawings. We have also been working on developing AI-powered applications around operational data insights. And these are predictive models that not only better visualize and contextualize data, but could help with business-related decisions. And of course, the ability of large language models and generative pre-trained data transformers to describe images, understand the context of what's there, and also make suggestions based on that has brought the rise of diffusion models like Midjourney, as we said. And at FNP, we could start creating our own AI portal that uses machine learning for image generation, but we want to do it directly through our design software like Rhino. So we have an ML portal that we're going to deploy office-wide, but we have been looking for over a year and a half of how we can do that, not just as an image exercise, but directly through the models that we create. So here you see us using Stable Diffusion hosted in our servers, where it gives different options around massings that our designers have used. And as these technologies evolve very quickly, and with the development of these diffusion models now, we can get results like this. And again, having our ML inference API in place allowed us to quickly deploy and experiment new models on the backend. And with these impressive results, when anybody can model anything in Rhino and write different prompts that give them different suggestions around the model they design. And we talked a lot about design, but obviously there is a plethora of software already out there for design but also construction and operation of the built space that uses machine learning and will totally revolutionize the way that we approach the design process. I don't think I have enough time to speak about that today, but I hope that I will have the chance to speak with some of you at some point around these lines. And I would like to leave you here with the applied R&D kind of waving with all these robots and their imaginary friendships. And hoping to see all of you soon in person. Thank you very much.
Thank you, Martha. Although she wasn't here live, we did enjoy her contribution, and obviously there's a blog post that we collaborated with her on. We posted the link in the chat, so if you guys want to check it out, it's all there for you. And we thought, in the spirit of this hackathon, you're obviously joining us from all over the world. There's 283 people registered coming from 40 plus countries, which is quite impressive. And to give some sort of a little twist to this, we thought we would go over some of the hashtags that have been already shared with us on social. So Mirna and I will be commenting on what you guys are up to. So let's go. Mirna, do you want to go Twitter or LinkedIn first?
Ooh, let's go to Twitter.
Okay.
Let's follow the Beyond the Speckleverse hashtag that we
Let's go.
love to remind you guys about. It's the way that we're gonna find your posts and your questions as well, to be able to offer you support and also stalk you like this and expose you out to the world. And here we have Tina joining us from, is it Uruguay?
Uruguay, yes, indeed. We're
Yes.
going to South America today, so she's actually drinking coffee. She's just sharing her experience live. And by the way, side note, this is what Mirna and I do every day at Speckle. We stalk you guys to capture your stories. So this is just a normal, regular Friday evening for us.
Yes, and in return, we like all of your stuff and comment how amazing it is. So it's a win-win for everybody here. So keep on sharing for sure. Definitely, like the atmosphere right now, it's 8 hours of hacking if you start it at noon or 1 or whatever, depending in the world, because you're really all over the world. So I'm guessing that you're like on your 5th cup of coffee at least. So
Oh, she's here. Yes, she's Tina.
Augustina, hi.
Well, we're
Yes.
exposing you, but we also see, I think you tagged your team, so we hope you guys are up to something good, and we're sending you luck and love. Let's look at another post here. Okay, what's happening here? Managed to build a quick roof. There's even a link, quick roof, and there's a link to the web app. So hopefully all of you are familiar with this environment. Otherwise, you wouldn't be doing this hackathon. We have a few comments here.
And this is perfect because we were just talking about the Project Pulse category, and you can see the team leveraging Speckle's options for bettering the communication and collaboration in the AEC right here, and you can see like a QR code. I didn't even know that was something that you do.
Yeah, this is pretty cool. I don't know what's going on here, but it looks like it's going somewhere. So yeah, pretty original project.
This is why we do what we do, because you guys come up with better ideas in 2 days than thousands of people might. So just keep on doing it, and please do share with the hashtag Beyond the Speckleverse so we can dig in.
Yeah. I'm gonna go to LinkedIn now because there's also a post, and I'm risking this because I'm sharing my profile, so I hope the team will not message me here and expose me. We are looking at Denitsa, and she even posted, she already recorded something. Okay, this is like no pressure, guys, but some people are pretty advanced already.
She is going for the win.
She
And
is.
yes,
She's really good.
holiday money incoming for Denita.
The $5,000 prize, huh? She's good.
Right? Not bad.
Um, and actually, I think this is a good moment to highlight that you can see here, of course, our amazing Jonathan is also on social commenting on people's posts from that specific hashtag. So if you guys are looking for real-time support from the one and only Jonathan, it's going to happen. And I think this is pretty cool. It shows that we're all over this weekend.
Yes, we are. The whole team is here. Team is here to support you. So whenever you have any questions, all of the social media is here. Speckle community is also here. If you haven't joined, please do, because that's where you get all of the support. Usually 24 hours a day. That's how it works with Jonathan, at least.
And I see also Tina replied, she's part of a team of 5. They're based in Uruguay, working on some scan to BIM fun. Okay, well, good luck, guys, and we can wait to see what you come up with.
Scan to BIM. I like the name.
Yeah.
I can't attest to the technology, but I can, as a marketer, say the name is catchy.
Yeah, we like it. We approve. A few things that we also wanted to share with you guys. We did come prepared for a live stream, didn't we? This is one last thing.
Okay, let's go.
We also have a DJ that is personal to this.
Yeah.
We have a map here that shows you where you all are, and it's pretty impressive. You're taking over the world, and we love to see it. So, South America, actually, all of the Americas are there. I also see North Africa. Love it. And what else, Mirna? Who are you excited to see perform?
Ooh.
What country are you supporting?
Ooh, I have to support Norway because I am based in Norway, but I also have to say that I'm really sad that nobody from Croatia joined. So I'm representing Croatia here as you are, Senda, for Tunisia. So
This is like Eurovision 2.0.
douze points for everybody from Mirna and Senda.
Yeah, I think all of this to say, guys, good luck. You'll see more of these live streams happening over the weekend. So this was the first one. Hopefully it gave you some motivation. And yeah, we wish you luck. Keep posting the hashtag, don't forget. And we will see you very soon.
Good luck, everybody. When you feel tired, just know we're here with you, awake with you all weekend. Whatever you need, reach out.
Okay, let's go.
All right, bye.